Hello from West Virginia. Hello from somewhere. Oh, I love this traveling because this might be the only way that I get to some of these places. Okay, but what I can get to every single day is Joke of the Day, and I know that you're ready and waiting, so let's get to it. Why do hamburgers fly south for the winter? I mean, hamburgers, why do they fly south for the winter? So they don't freeze their buns. This is great. Okay, the other thing that's great is imaginary numbers. Now we're going to go into the imaginary world. No, I'm not a magician here, but we're going to talk about some very strange types of numbers that are very important to use. So let's get first the definition of an imaginary number. You know that when you take the square root, you're simply saying to yourself, what would I multiply by itself to create the number that's underneath that radical? For instance, if we saw square root of 9, we would say the square root of 9 is going to be a 3, because 3 times 3 will give us 9. But we also know that the square root of 9 could be negative 3, because what's negative 3 times negative 3? Positive 9. So we could either get a positive 3 or a negative 3 for that square root. However, what happens when there's a negative underneath that radical and I try to get square root of a negative 9? Because that means what would I multiply by itself to create that negative 9? Well, see, positive 3 times positive 3 is a positive 9, and negative 3 times negative 3 is still a positive 9. So there's nothing that I can multiply by itself to create that negative number that's underneath the radical. So whenever we see something like that, we are stuck. We can't move on. We can't evaluate it. But if we utilize imaginary numbers, now we can evaluate negatives underneath radicals. So the definition of an imaginary number is the square root of a negative number. So by definition, if you see a negative 1 underneath the radical, that is the equivalent of I. So whenever you see a negative underneath the radical, you think I. Now, let's take a look at expanding that a little bit. So if I is the square root of negative 1, if I would square that I, then that means I'm going to square this as well, square root of that negative 1 squared. But we know that squaring and square rooting do what to each other? Yes, they cancel each other out. So I'm simply left with a negative 1. So by definition then, the I is going to be a square root of a negative 1. And by definition, I squared is going to be a negative 1. And these two rules are the two basic rules that we need in order to be able to evaluate our imaginary numbers, or in other words, evaluate whenever we have a negative underneath the radical. Now we can create higher powers of I. The definition that we just received, well, we know anything to the first power is itself. We just found out that I squared is a negative 1. Now I to the third, we can figure that out because we have laws of exponents. Laws of exponents tell us that if we take an I squared times an I, we're going to add those exponents, and a 2 plus a 1 will give me a 3, but we just discovered that I squared was a negative 1, so this is a negative 1. So what we really have is negative 1 times I, which is just a negative I. Now if we do I to the fourth is going to be I squared times I squared, or if you prefer, you could look at it as I times I to the third. Either way, I'll show you how that it's going to come up with the same thing. Now remember, I squared is a negative 1, so what I have here is negative 1 times negative 1. And well, negative 1 times negative 1 is 1. Now remember, I said you could look at this as I times I to the third, but remember, I to the third was a negative I. So this is going to be I times negative I, and actually let me put this over here. I times I to the third is going to be I times negative I. That's going to be a negative I squared, but I squared was a negative 1, so I have the opposite of negative 1, which is a positive 1. See, I'm still getting back there. So I to the fifth, I can look at it as I times I to the fourth, or I can look at it as I squared times I to the third, or however you want to look at it. Now remember, we just figured out that I to the fourth is a 1. So this will be I times 1, which is just an I. Now I know that this is getting exhausting, but we'll get here to the bottom here in just a minute. I to the sixth is I times I to the fifth. We just figured out that I to the fifth was an I, so we have I times I, which is I squared, and we figured out I squared was a negative 1. Okay, I to the seventh. It's going to be I times I to the sixth. but we just figured out I to the 6th was a negative 1. So this is I times negative 1, which is negative I. Are you noticing something? I am too. I bet money that this one down here is a 1. Let's see if that happens. So this will be I times I to the 7th. We just figured out I to the 7th is a negative 1, so we have I times negative I, which is a negative I squared. And I squared is a negative 1, so this is going to be the opposite of negative 1. And just like we saw here, that's going to be, yep, like we called it, a 1. What do you notice? Yes, we've got a set of 4 here. I, negative 1, negative I, 1. I, negative 1, negative I, 1. And you're absolutely right. The pattern repeats every set of 4. Pattern repeats every set of 4. And this allows us to be able to simplify higher powers of I. Let's take an example here. We're going to evaluate the quantity 6i. That quantity is being squared. Now remember, what that indicates is two things. One, it indicates that that means 6i times another 6i. But it also indicates I can distribute the power like we've discussed before. And I can distribute here and here because 6 squared and I squared is going to be the same thing that I get out of here, because 6 times 6 would be 6 squared. I times I would be I squared. Now I know that 6 squared is 36, but I also know that I squared is a negative 1. And 36 times a negative 1 is a negative 36. So see, it allows me to evaluate. These are the two basic rules that you need to know. All this higher power of I, I'm going to tell you the truth, I don't have it memorized. You noticed I created all this? I don't have any of it memorized. The only thing I have memorized is right here, which is here, I squared equals negative 1, and then an I is the square root of a negative 1. And that's all I have memorized. But that's all I need, because I can create the rest of this, and this is the most important thing here. Which, take a look at this. Let's take a look at the idea of a principal square root of a number. Because remember, this all started with me saying, what happens if I have square root of a negative 9? I don't know what to do with that. Now what I do know is square root of negative 1. I do know the square root of negative 1 is an I. But this square root of negative 9, I don't know what that is. But remember, we had a product rule for square roots. And that product rule for square roots said that if I have two things that are multiplied underneath their radical, I can separate them into their own individual radicals. So I can look at this negative a as a negative 1 times a. And my product rule said I can take those two factors, that negative 1 and that a, I can separate them out into their own individual radicals like this, and multiply those radicals together. And aha! We just said square root of a negative 1 is going to be an I. So this is really just an I times the square root of a. And so that leads me to the ability to simplify whenever I have a negative underneath the radical. When you have a negative under the radical, all that you do is you take an I out, you leave the other factor underneath, and simplify that radical if you can, looking for perfect squares and pairs, just like we've been talking about for some time now. So here again is the basic rule that you need to know. This piggybacks on this idea right here, that the definition of the square root of a negative 1 is I. So all you really need to know, two things. One, when you see a negative underneath the radical, you take an I out, simplify the radical. Two, I squared is going to be a negative 1. Those are the two rules that you need to have. So let's use those rules to be able to simplify these radicals. Take a look at this first one. It says evaluate a negative square root of a negative 49. See, I'm looking for a number that I can multiply by itself to create a negative 49. But see, 7 times 7 is 49. Negative 7 times negative 7 is positive 49. There's nothing that I can multiply by itself to create a negative 49. So if I utilize my product rule and I say, well, that negative 49 is a negative 1 times 49, and my product rule said I could separate those out into their own individual radicals, and I know that the square root of a negative 1 is just an I, and I know that the square root of 49 is a 7, then ta-da, I've got it. Now you may be thinking, now hold on a second. You said that the square root of 49 is going to be a positive 7 or a negative 7. But remember that idea of principal square root, that if it's already on the page, I don't have to think about the positive or the negative. So therefore, I'm just simply going to say that the square root of 49 is a 7. Now, typically we don't write it this way. I know I circled it. I did that prematurely. Just like if you have a term, say for instance 7x, you never write it as x7. You always put the coefficient, the number in the front and the variable in the back. Same thing here, because quite frankly, I acts like a variable until you see I squared, and when you see I squared, you think -1. So right now, it's kind of this funky little variable sort of thing, reminding us that this really was a square root of a -1. My point is simply this. Write your 7 in the front, write your I in the back. So when you evaluate square root of -49, honestly, you don't have to go through all these steps. As I went through all the steps so that you could see how you could very quickly arrive at 7i, because like I said before, when you see a negative underneath the radical, take that I out, deal with the square root. So here I'm going to take that I out and I'm going to deal with the square root of 49. And I know the square root of 49 is 7. So I could quite frankly go straight from here to here and be done. I don't have to go through all these steps. But I wanted you to see all those steps so that you understand why it is just a 7i. Now, let's take a look at these 3 examples that say we're going to simplify each one of these. Remember that product rule did say that we could take 2 radicals that are underneath and we could put them together as one big radical as long as the radical is the same. And they are the same here. But I do need to caution you, whenever you have a negative underneath the square root, crazy things are going to happen. You need to deal with those negatives underneath the square root first and foremost. Let me show you why. If I use my product rule and I go ahead and put them together, and I'm going to slide that over here so I have plenty of room, what's going to happen is underneath that radical I'm going to have a -100 and I'm going to have a -81, and I'm going to multiply those 2 together, and when I do, negative times negative is positive, and 100 times 81 is going to be an 8100. Now I'm looking for the number that I can multiply by itself to create an 8100. That's a 90. 90 times 90 is going to give me an 8100, and I'm still dealing with principal square root. So I'm not worried about the -90, just the positive 90. However, again, caution. When you have a negative underneath the square root, you really need to deal with that negative first. Watch what happens when we deal with this properly. So here, like I said before, when you see a negative underneath, take the I out. So I'm going to take the I out of here and get I square root of 100. But I'm as well going to take the I out of here and get I square root of 81. Now, I know that the square root of 100 is 10. So I have 10i here. I also know that the square root of 81 is 9. So I have 9i here. Remember, I'm dealing principal square roots because it was already on the page. So even though, yes, -10 times -10 will give me 100, I'm not worried about the negative part. And as well, -9 times -9 will give me 81. I'm not worried about the negative part. Now I'm going to multiply these together. And remember, multiplication is commutative and associative. It doesn't matter the order you multiply. So therefore, I could go ahead and multiply the 10 and the 9 together, 10 times 9, and then I can multiply the I times the I together. Well, 10 times 9 is 90. I times I is I squared, and aha, there it is. I squared is what? -1. So this is actually a -1, and I have 90 times -1. And what is 90 times -1? It is a -90. See, when I did not deal with those negative underneath the radicals and I just went ahead and put them together, I got a positive 90. So I don't want to do that. And again, my point is simply this. When you have negative underneath the radical, deal with that first. Take care of your principal square root of that negative number. Take that I out of there. Then go from there, following all those properties and laws for square roots that you've got. So with that in mind, let's take a look at this one. Again, I'm going to simplify. I see negatives underneath the square root, so that means I'm going to take that I out of there first and foremost. So I'm going to take the I out of here, and I'll get a square root of 5 underneath. I'm going to take the I out of here. I'll get a square root of 10 underneath. And now I'm going to multiply all these together. And like we said before, multiplication being commutative and associative, I can reorder and regroup. So I'm going to put my square root of 5 and my square root of 10 together. I'm going to put my i's together. Now, For that square root of 5 times square root of 10, remember, product rule says I can keep them separated, I can put them together. This allows me to simplify. So I'm going to put them together underneath one big radical, 5 times 10. And that I times I, remember that's going to be an I squared. Now, the square root of 5 times 10, remember I'm looking for perfect squares or pairs. I cannot think of a number that I can multiply by itself to create a 5. Nor can I think of a number I can multiply by itself to create a 10. So when I put them together, now I can call it square root of 50 if I want, or I can just simply break it down, break it down, break it down, start breaking those things down. Yeah, I grew up in the 80s. We were breaking down. So we're going to break it down until we find perfect squares or pairs. So that 10 is the same thing as 5 times 2. Aha, I see a pair of 5s. And when I see a pair, I'm going to take one out, and it's going to dissolve the other one. So I'll take one out, dissolve the other, because remember, 5 times 5 is 25. The square root of 25 is just a 5. That's why you take one out and it dissolves the other one. It's not magic, it's math. But anyway, so it's going to come out. Don't forget that I squared that's in the back. So I'll have the 5 out, square root of 2 there, and that I squared. I'll put this down below because I'm running out of room here. So 5 out, square root of 2. And remember, I squared is what? There it is, negative 1. So this is really a negative 1 times all that. So that indicates I have a negative 5 square root of 2. It is simplified. Okay, last one. So in this one, notice I have an I squared. I squared is what? Negative 1. As soon as you see that I squared, you should automatically be thinking negative 1. So this is going to be 4 times that negative 1. Now I to the third, remember I told you I don't have any of those higher powers memorized. So for me, what I'm going to do is I'm going to say that I to the third is going to be I times I squared. Aha! I squared is a negative 1. So this is a negative 1 as well. So here, 4 times negative 1 is a negative 4. Minus 2 times I times a negative 1. And negative 2 times negative 1 is a positive 2. So I have a negative 4 plus 2i. And remember, I acts like a variable until you see I squared. The minute you see I squared, bam, 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 you should be thinking negative 1. But if you don't see I squared and you see I, you should treat it like a variable. That's what I did here. I treated I to the third like a variable. And I said, well, it's kind of like x to the third. And x to the third is the same thing as x times x squared. So I'm treating it like a variable until I see that I squared. Bam, negative 1. And so I'll insert the negative 1 at that point. But now I'm treating it like a variable. And so it's going to be a 2i. So I hope that, and because I'm treating it like a variable, these two cannot go together. Because if it was a negative 4 plus 2x, you would not put those together because they're not like terms. These are not like terms because that does not have an I with it, so I cannot put them together. So I hope that this helps you with the idea of the imaginary number, the imaginary I. And remember, 2 things that you need to remember. I shouldn't have flipped this over. The 2 things that you need to remember are when you see a negative underneath the square root, you take that I out. Then you deal with the square root of that number. And when you see an I squared, bam, think negative 1. I hope it helps. Have a great day.